Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. So we have reached into the fourth section of CTQ where we are learning the concept through the question for the control system, and obviously our mission is for GATE 2022. What are the different branches are going to get benefited from this particular module? Obviously, electrical, electronics and instrumentation, all of three branches are going to get benefited from this module. This has been the fourth module. Agreed? Okay. In the same sequence, let me go ahead. Let me briefly discuss about the schedule which we had over the GATE Academy Global on different subjects which we have been dealing with the form of CTQ. The first subject is being electrical machine. Precisely at 1 p.m. we used to start, and the subject expert who used to take this particular subject is being Bhanu sir. Probably the classes is already going on. Electrical as well as instrumentation, both of the stream are going to get benefited from this particular subject, because in GATE 2021 the additional subject electrical machine have also got included for the instrumentation people. Keep in mind it would be 5 days in a week from Monday to Friday. And similarly, the power electronics, this particular subject is exclusively for the electrical people alone, and that would be 2 days in a week on Saturday and Sunday. Again, the Bhanu sir is going to take this class, and precisely the timing would be 1 p.m. That means the Bhanu sir is going to take precisely at 1 p.m. class on daily basis. Starting 5 days would be for electrical machine, electrical as well as instrumentation, both are going to get benefited. Last 2 weekends would be dedicated for the electrical people only, and that's gonna be power electronics. Similarly, the third subject which is going concurrently, it's being taken by me, and that's been the control system. Precisely at 3 p.m. we would be meeting at daily basis. And obviously electrical, electronics and instrumentation, all of three streams are going to get benefited from this particular subject. Fourth subject which is running parallelly, obviously in daily basis, it has been in daily basis, power system analysis, and precisely at 6 p.m. the Vishnu sir do come on our GATE Academy Global, and this subject has been exclusively for the electrical people alone. In the same sequence, the EMFT, Karthik sir used to take this classes. It would be daily basis, precisely at 6 p.m. Starting 6 to 7 days, this particular class would be dedicated to the electrical, electronics and instrumentation, all of three branches. But in future it would be dedicated towards electronics alone. After 7 to 8 days, basically the important part of the electrical as well as instrumentation, which has been the electrostatics as well as the magnetostatics, would get covered over this particular module. And similarly, the last subject of the day would be network analysis. Precisely it used to take place at 9 p.m. daily basis. Diptanshu sir used to take these classes. So the first subject, second subject, third subject and fourth subject, this has been subject for the instrumentation. First subject, second subject, third subject, fourth, fifth and sixth, it has been for the electrical, and for electronics it had been the first subject, it has been the second subject, and it has been the third subject. So I would say write it somewhere so that you will have enough idea that how you will follow our complete strategy over the GATE Academy Global. All of the lectures are supposed to come on GATE Academy Global, and there the mode of communication is going to be in English. Agreed? In the same sequence, let me straight away hop into the next question, and this would be the first question of the day. My dear friend, in last class we were discussing a bit about the initial conditions as well as final conditions, or the initial value theorem as well as final value theorem. With the help of initial value theorem as well as final value theorem, we are going to crack few number of problems which has been experienced by the people in the different GATE examination. This problem has been experienced by electronics people. GATE 1995, the problem was framed by IIT Kanpur. Let me read the problem word by word, and you had to give its precise most answer over the live chat. The problem states, the final value theorem is used to find the four options were attached along with this problem. It's been a steady state value of the system output, initial value of the system output, transient behavior of the system output, none of this. Tell me what would be the best most answer for this given problem. So it has been a theoretical based problem. It should not take more than 10 seconds. Once you have studied this problem thoroughly, it should not take more than 10 seconds. Tell me what would be the best most answer for this given problem. So the answers have started coming. Pawan Smart says A, Amit Kumar says A, Rajit Kumar M says A. Obviously, Pawan Smart, Pawan, I need not to put the same option again and again. Obviously, I got your answer. Obviously, the A is gonna be the precise most answer. Precise most answer. Let me go briefly about its background. The final value theorem, which we have discussed in the last class, talks about the state of the function when t tends to infinity. Let's take, I have taken an example. We have got a system. The system has been excited by a certain input x of t and had the output y of t. Let's take, had the output y of t, and it has been excited with the x of t. Let's take the Laplace of the output is being taken as y of s. And as you have been interested, finding the value of y of t when t tends to infinity. It's also called the final value of y of t, because the final most value or the largest most value of t could be infinity. So that is why it's also called the final value of y of t, which is also called steady state value of y of t. So there are two different methods. Either mathematically, you can feed t tends to infinity, from there you can get the final value of y of t, or you can also use the final value theorem. The final value theorem states, if you know the Laplace transformation of y of t, from there also you can conclude limit t tends to infinity y of t, and that has been seen in last class. It's been limit s tends to 0, s times of y of s. So if somebody would ask why the final value theorem is being used, so obviously the final value theorem is being used for the calculation of steady state value of y of t when the t tends to infinity, or the final value of y of t. Agreed? But one more important thing we can conclude out of it, whenever you have a response, now in time domain I am saying, whenever you have the response in time domain, basically it would have the two part. First is gonna be transient part, and second is gonna be steady state part. Any of the control system would have a transient as well as steady state part. If I give an example, like if you switch on your ceiling fan, for a starting moment of time, its rotation per unit time is gonna be lesser. It would pick up its speed, and end of the day it would rotate with its steady state value, or I can say with a finite steady state RPM. Could you understand? So that is what I am saying. Either you take fan rotation would be keep increasing. After certain amount of time it would go into the steady state and it would be moving with a constant RPM. So the transient part, the part at which the RPM was function of time, and similarly the steady state part when it reached to a constant value of RPM. Not only that, even if you'll switch on any of the appliances, like if you have switched on a motor, the starting current which would be sunk by the motor would be larger, and after certain amount of time when the settling takes place, what happens, the amount of current which has been sunk by the motor reduces to its steady state value. So what I am saying, whenever you talk about the response of any kind of system, either it's a control system in electrical domain or mechanical domain or electronics domain, always you will have the two part, transient part as well as the steady state part. Although being a designer, I want the transient part to be the least as possible as is possible. I would expect whenever I switch on the fan, it should start taking the steady state RPM itself, but that's not possible because it has got initial inertia, it was in rest, so obviously it is going to take certain amount of time to reach the steady state. So what I'm saying, whenever you talk about the response, no, the response is gonna be the two part. I may call it the transient part. The transient part would always be the function of t, because with respect to the time it is going to change its value. With respect to the time it's going to change its value. Either it could be RPM of the fan, either the current sunk by the motor. Obviously with respect to the time it's going to change. And now here goes the steady state value. Steady state value could be the function of t, and even it could be independent from t itself. See, try to understand in this way. Many of the times I have seen the student used to have one doubt that why SS would always be a constant value. Need not to be. My dear friends, if the input itself is being changing with respect to the time, obviously the steady state is not gonna be time independent. It would be time dependent. Like if the system is being excited by a sinusoidal signal, in that case the input itself has been changing with respect to the time, then how you can say the output steady state would not change with respect to the time? It can change with respect to the time. So y of t would always be the function of t. YSS could be the function of t, or it could be a constant value depending on the type of excitation. If the excitation is being changing its worth with respect to the time, definitely the response would also be the time dependent, and if it is not been happening, so obviously it's gonna be a constant value. Yes, agreed? No? So from here if YSS is known, no, even you can get the value of YTR also. See how? If you have been interested finding the transient part of your response, what you can do? The complete response IT must be known to you. What you can do? You can subtract YSS, and YSS could have been calculated using the final value theorem also, and that would be limit t tends to infinity could have been written as limit s tends to 0 s times of y of s. So more or less you can also say the final value theorem can also be used for finding the value of YTR virtually, but this is not the direct calculation of the transient part. So out of the 4 options which has been attached along with this problem, which starts from steady state value of the system output, initial value of the system output, transient behavior of the system output, the best most answer is going to be option A. Option A. The A is going to be the best most answer. So few of the critical finding which we can conclude out of this problem. The first thing, many of the students used to have one doubt that sir YSS would be a constant value always. No, not necessary. If the input or the excitation itself is being a time dependent function, so obviously YSS is also going to change with respect to the time. You can take an example of AC signal is exciting a transfer function. Obviously the output would also be time varying in steady state form. That's the first thing. Second, why it's called steady state, or why it's called the final value theorem. Keep in mind, this theorem is also being called as a final value theorem because it calculates the final worth of y of t. May I know how do we calculate the final worth of the y of t? The maximum worth or the final worth of y of t would be always at t tends to infinity. So obviously it's also being called as a final value theorem. So the student who have given the answer as A, it's been a perfect most answer. It's been a perfect most answer. Now in the last class we were discussing a bit about the validity of the final value theorem. May I know what is been the validity of the final value theorem? What is been the validity of the final value theorem? Obviously the validity is been all poles. What does it mean by the poles? Roots of the denominator's polynomial. All poles must be having negative real part or must be towards the left hand side of S plane. Must be having negative real part. So from here onwards you can by heart this formula, because in examination you will not have that much time that you would derive this formula. So in future, if you have been interested finding the final response of y of t or final value of y of t, that means obviously t must be moving towards infinity. If you know the value of y of t, you can use the method of limit. You can post the value of t tends to infinity. From there also you can get the value of y of t when the t has been tending towards infinity. But rather knowing y of t, if you have been knowing y of s, you need not to convert into the form of y of t, because that's a very time taking as well as painful process. So rather converting y of s into the y of t, straight away you can apply this process, and that has been limit s tends to 0 s times of y of s. I have seen the two important points where many of the students get stuck. First, t tends to infinity. Many of the times what they do in hurry, the student used to write limit s tends to infinity, which is utterly wrong. And similarly, sometime even student forget to multiply the s, that is also wrong. And sometime the worst of the worst situation, I have also seen the student used to have one mistake they used to commit. They do not see whether the y of s has been a valid function for applying the final value theorem or not. Yes. So till this point, I don't find any of the student would have any sort of doubt now. Agreed now? Just a minute. Yeah. In the same sequence, let me move forward. May I know what used to be the initial value theorem? So let me briefly discuss about the initial value theorem also. Initial value theorem. Yeah. As like we were talking about the final value theorem, where the value of y of s was known, and with the help of y of s we were finding the value of y where the t was tending towards the infinity. Now in the same sense, if you had the value of y of s in your hand, with the value of y of s you wanted to calculate the value of y of t when the t has been reaching almost equals to of 0, or which is been at a initial value, Could you understand what I'm saying? So what I wanted to say over here, tell me, if you had a function in time domain, this could be the function, it could be the response of the system, it could be the input, it could be the output, it could be anything. I have not been bounding myself towards output side, towards input side, no. That is why I have just calling it had been a function of time domain. So what I'm saying, this value has to be assessed around t is equals to 0. So obviously with the help of limit and all, or easily we would be able to get the limit t tends to 0 y of t. But I had a certain situation. We had the Laplace form of y of t, and that has been y of s. So the first methodology could be, you had to take the Laplace inverse of y of s, that would become y of t, and then you had to feed limit t tends to 0. Unnecessarily we are losing our effort as well as time. Definitely we can straight away we can use the value of initial value theorem. And what the initial value theorem states, see, earlier when the t was tending towards infinity, the s was tending towards 0, but now as the t has been tending towards 0, the s would tend towards infinity, and here also the same process gets followed, and that's been the s gets multiplies. Agreed? No? I would like to have one input from each one of you, as the final value theorem had its limitation, whether the initial value theorem has certain limitation or it can be applied everywhere. If you understand, or if you know, or if you feel a certain type of limitation the initial value theorem do also exist or also contain, you write limitation, otherwise you say no limitation. Because I know this is also the point where many of the students may do the mistake. Tell me. So the two important conclusions which we have retrieved, it's been the initial value theorem as well as the final value theorem. In final value theorem, it has been categorically said the final value theorem has to be used only and only with the value of y of s, where its poles should always have the negative real part. Prabhakar Silvam says, no, most of the time the initial value theorem is not at all used. In practical, always we interested finding the steady state response, like steady state RPM of your fan, maybe steady state current sunk by your motor. So what I'm saying, but still mathematically we have got a certain bridge where the initial value can also be calculated using the transformed form of y of t also. That is why we read exclusively. And if you'll see in GATE, out of 10 times, the 8 number of times the usually problems are going to get asked from the steady state, and very minimal times the questions are being framed on the initial conditions. So obviously the final value theorem is more important than the initial value theorem. So the Hers have given one answer, strictly proper LT for IVT, and as per the Amar Viswas, the Amar wanted to say, sir, it does not have any limitation as the final value theorem had. Anyone else apart from Amar as well as Hers? Strictly proper function, only we use initial value theorem. Yeah, agreed. So what I am going to do over here, let me discuss briefly about its limitation part. So here goes the limitation of initial value theorem. The transformed form of y of t is being y of s. Obviously it would have its numerator part as well as denominator part. You'll have a polynomial towards the numerator side as well as you'll have the what? Polynomial towards the denominator side. Let's take the polynomial which we had. It's been a n, we can write s to the power of n, a n minus 1, s to the power of n minus 1, and if it keep goes on, a1 into s, and at last it becomes a0. So may I know what had been the degree of the polynomial? The degree of the polynomial had been n. of numerator. Similarly, towards denominator side we had bn s to the power of m, a m minus 1, m minus 1, s to the power of m minus 1, and it goes till b naught, b naught. So as we know, the degree of s dictates how many number of roots you will be having towards numerator as well as denominator. The number of roots of numerator's polynomial is also called number of zeros. How many number of zeros we had? N number of zeros we had. And similarly, how many number of poles we had? M number of poles we had. M number of poles we had. As per the limitation of initial value theorem, the initial value theorem is valid only and only if m is greater than n. That means the number of poles has to be greater than the number of zeros, or the given function has to be a strictly transfer function, or strictly a proper transfer function. The proper transfer function is a transfer function which had the number of poles greater than the number of zeros. Even it can't be equals to also. So both had got its own limitation. It had the limitation that the number of poles which had been there with y of s, those all part has to be negative real part. And similarly, in the same sequence, if we'll go ahead with the initial value theorem, although it had been the outcome of the initial value theorem, but it has also got the limitation that the m should always be greater than 1, or the given transfer function y of s has to be a proper transfer function. Now, many of the students would also have one doubt, sir. Although logically you have been said, okay, the system has to be a proper transfer function, then only the initial value theorem would be valid. But now I would like to raise one question. What is the basis behind this? See, if this limitation have come in front of you, there must have a certain basis for that. May you know what's the basis? If you have a non-proper transfer function, what's the problem you will be having? That you would not be able to calculate the initial value with the help of initial value theorem. Tell me, if you guys are having a certain idea, you can put it over the live chat. What I am saying, most of the students have replied it very perfectly. As per them, they are saying the initial value theorem concept can be used only and only when we have been using a strictly proper function where the number of poles has been greater than the number of zeros. Not even m is equals to of n would be a perfect proper function. M has to be greater than n, or number of poles has to be greater than number of zeros. Why so? I am raising one question. Why so? Because just try to understand in this way. Let me take one or two number of example. That example itself is going to explain a lot. Let's take you had a function of y of t in Laplace, which is been y of s, and let's take this is been s plus 2 divided by of s plus 1. Yeah, till this point nobody should have any doubt as such. But before applying the initial value theorem, I would like to ask from each one of you whether it had been a strict proper transfer function or whether it had been a strict non-proper transfer function. So obviously it had been a non-proper transfer function. Now many of the students would say, sir, then what's the problem we used to have such that the initial value theorem we don't apply? You yourself would be able to understand it. Why? Just try to understand this way. What we are going to do, we are going to take the Laplace inverse of y of s. From there the things would be clear. For that the partial fraction has to be carried out. So s plus 2 could have been written as s plus 1 divided by s plus 1, which would be 1 divided by of s plus 1. 1 divided by s plus 1. Yeah. Now what is happening over here? If I calculate the Laplace inverse of y of s, that would be y of t. May I know what would be the Laplace inverse of 1? The Laplace inverse of 1 is simply going to be, tell me, what's going to be the Laplace inverse of 1? The Laplace inverse of 1 is going to be delta of t. Yes, if you have unit impulse function in time domain or in continuous time domain, that results 1 in Laplace domain. in Laplace domain. And here it goes. If you talk about 1 upon s plus 1, it has been a well behaved function. As such, there is no problem with this. It's been e to the power of minus t into u of t. If you will try to draw this particular time domain function over graph, you yourself would be able to understand what used to be the nature of e to the power of minus t into ut. It would be decaying exponent function which starts from t is equals to 0 with the magnitude is equals to 1. Magnitude is equals to 1. Yeah, so it would be sort of this. It would be sort of this. It had been e to the power of minus t into u of t. And that has to get added with the del of t. Keep in mind, del of t is not been defined practically, and even mathematically del of t had got the different kinds of understanding or different kinds of explanation. But one thing is being quite sure, the del of t is going to get concentrated along t is equals to 0 or along y-axis itself. And once you'll add this and this together, and as far as the initial condition or initial theorem condition is initial value theorem is being concerned, we have been focusing over the magnitude at origin. And obviously the delta of t had its problem. Once you'll add them together, no, at least at t tends to infinity, you can say, sir, obviously the steady state value would again be 0, because once you'll add them together, whatever the discontinuity or discrepancies would be found, it would be found at t is equals to 0. Towards t tends to infinity, there is no discrepancy because of unit impulse. But as there had been a big discrepancy at t is equals to 0, I would not be able to calculate the initial value of this complete function. Yes, that is why initial value theorem, no, it's not been applied. So that is what I am saying here. Where the final value theorem is not been applied, the final value theorem cannot be applied for those functions which are not converging to a finite values. And now here also the initial value cannot be applied where it has not been converging to a final value. It has not been starting with a finite value, with the finite value. Could you understand what I am saying? So now many of the students must have been by hearted that m has to be greater than n, then only the initial value theorem can be applied. Could have got a little bit insight about the complete theory. Not only that, if I take the next problem, the problem is been like what we can take. So far the number of poles and zeros were same, and now deliberately I have been designing a transfer function where the number of zeros are greater than the number of poles. So which type of function we can have? We can have like this: s square plus of 2, and here you can have like s plus 1. And once again, if you'll go for partial fraction, and once you'll take its Laplace inverse, no, earlier y of s had 1, but now you will be having s now. And definitely along with the s, you will be having few more components. But may I know what used to be the Laplace of s? I know the Laplace inverse of 1 is being a del of t, so the Laplace inverse of s is gonna be des of t, and that's nothing but the singlet, doublet. I am not going into the detailed analysis, but one thing has been quite sure, it's been a delta des of t. Again, this part would remain as it is. Now again the same problem have come in front of you, and what it is, sir, delta des t has not been a well behaved function, and precisely its worth at t is equals to 0 cannot be assessed, and hence initial value theorem cannot be applied. So may I know what's the conclusion we can retrieve out of it? Whenever the poles of y of s goes towards right hand side or had a real part as a positive, this tries to go towards a plus infinity or minus infinity, or sometime over the j omega. If the pole takes place, what happens? It is being keep oscillating. So what I tried to say, until and unless the response does not converges to a finite value, the final value theorem cannot be applied, and forcibly for that y of s, if the final value theorem has been applied, the result which we are going to get, it's going to be absolutely wrong result. Absolutely wrong result. In the same sequence, we wanted to discuss a bit about the initial value theorem. In initial value theorem, now the initial value of y of s must be well behaved. So can I know when the y of s would be well behaved at t is equals to 0? It would be well behaved only and only there should not be presence of del of t, there should not be the presence of del dash t, del double dash t, or I can say there should not be presence of impulse or maybe doublet or maybe triplet function. May I know when the impulse, doublet and triplet function concept would come? It would come only and only if the number of zeros are greater than the number of poles, or I can say the degree of numerator is greater than the degree of denominator, or I can say when the value of n is greater than m. So we had to ensure that the m has to be greater than n such that there would not be any presence of delta of t, and when delta of t or del dash t or del double dash t, it's not taking place at t is equals to 0, everything is improper, in order. So I would like to ask from each one of you, this concept has been clear to all of us? If you guys are having any sort of doubt, you can put it over the live chat. Otherwise, we are going to go forward. Go forward. So these two important concepts as well as their limitations must be known to all of us. Apart from the exclusive limitation which has been attached with this, and the exclusive limitation which has been attached with this, there has not been any limitation at all. There is no limitation apart from all of the poles has to be towards left hand side. There is no limitation apart from the number of m has to be greater than n. Tell me. Okay. So let me do one thing. Let me frame few number of questions, and I would like to ask only one thing: whether the final value theorem is being valid for that given y of s or not, and similarly the initial value theorem has been valid for that given y of s or not. Let me take the first question. Here goes the first question. In first question, I have taken the transformed form of y of t in Laplace domain. It's been y of s, and let's take it's been written as 1 upon s minus 1. I would like to ask from each one of you whether the initial as well as final value theorem can be applied over this function or not for getting its final value as well as initial value in time domain. This has been the first question. So you had to comment for the initial as well as final value, both. In the same sequence, let me move forward and let me take the next question. And here goes the next question. 1 upon s square plus of 1. In the same sequence, let me take the third question. Y of s is equals to 1 upon s square into s plus 1 into s plus 1. So the answer have started coming. According to the Hers Kumar, for the first question, final value theorem cannot be applied. May I know why it's so? Because only one pole we have got it for this given y of s. How do we get that? Comparing the denominator's polynomial with 0. So s has been plus of 1, and as it has been pure real and its real part has been positive, so obviously final value theorem cannot be used over here. In the same sequence, if we talk about initial value theorem, for the initial value theorem, I do not have any limitation apart from the number of poles as well as number of zeros. So we can see the number of zeros has been 0, number of poles has been precisely 1, or I can say the number of poles were greater than the number of zeros. So obviously initial value theorem is ready to be used over here. Yeah. So I would like to ask, after applying the initial value theorem, what we are going to get the value of y of t at t is equals to 0. So obviously what I am saying, limit t tends to 0 y of t or I can say the value of y of t around t is equals to 0 can be calculated using the initial value theorem itself, and that it indicates limit s tends to infinity s times of y of s. What had been the y of s? It's been 1 upon s minus 1. 1 upon s minus 1. How much worth we would be getting? So probably all of us must be very well acquainted while calculation of limit a certain variable has been tending towards infinity. So what we are going to do over here, the s would be taken common from numerator and denominator. It would become 1 minus of 1 upon s, and put together the result what we are supposed to get is going to be 1 minus of 1 minus of infinity, and the result would be simply equals to 1. Simply equals to 1. If deliberately, without going into the limitation, if I have used the final value theorem, see what is happening over here. This is simply going to be limit t tends to infinity y of 2, and from the final value theorem it's going to be limit s tends to 0 s times of y of s, that's been a 1 upon s minus 1, and it would be simply equals to 0. It would be simply equals to 0. And now graphically you would be able to see it clearly. Y of s, which had been 1 upon s minus 1, is being the Laplace inverse of e to the power of plus t ut, and how the e to the power of t ut would look like in time domain. Obviously it would be exponentially raising function, sort of this, and it would go towards infinity. So obviously you can see through the initial value theorem, whatever the initial value of y of t was predicted, it looks perfectly well. But with the help of final value theorem, whatever the prediction has been made towards t tends to infinity, it seems to be wrong. So only two limitations you should have in your mind. First limitation, in terms of final value theorem, all of the pole has to be towards left hand side of the S plane, and whenever we apply the initial value theorem, we should have one thing in mind, and the number of zeros should always be lesser than the number of poles. Now in the same sequence, let me take the question number 2, initial as well as final value theorem. Again the same thing has to be there in your mind. 1 upon s square plus of 1, if you will take its location of exact poles, the poles has been located at plus minus j. So obviously the final value theorem is not going to get valid over here. Final value theorem is not a valid theorem, at least for the calculation of final value of this particular function. No, it would not be. Obviously initial is happy to be used over here. And probably for the final value theorem, if you'll apply the final value theorem, you yourself would be able to understand how much value you have been getting. For the final value theorem, what you are going to do over here, just try to understand. You would be doing limit s tends to 0, and here it gonna be s, and here it would be 1 upon, yeah. So that is what I am saying. Sorry, infinity. Yeah, it's been an infinity. So the final value theorem should not be used, as I have been said over here. Final value theorem should not be used, but if you will use the initial value theorem, yes, you would be getting the perfect most answer. So okay, let me use the initial value theorem. Initial value theorem. So according to this, it's gonna be limit s tends to 0, infinity, s times of y of s, and here it becomes limit s tends to infinity, s gets multiplied with 1, that would be s divided by s square plus of 1. May you know what would be the worth of it? It's gonna be 0. Why so? Because in mathematics we have read so many times, if the number, or I can say the degree of denominator is larger than the degree of numerator, and if the variable worth has been tending towards infinity, the result would be 0. If the degree of numerator is larger than the degree of denominator, the resultant would be infinity. If the degree of numerator as well as denominator is being same, the resultant would be a finite value, neither 0 nor infinity. Yes, but many of the times what the people do, they won't ask what would be the final value of 1 upon s square plus of 1. They would ask what would be the bounded value of 1 upon s square plus of 1 at steady state. One thing has been quite sure, the final value theorem cannot be applied. but we can calculate its Laplace inverse, and from Laplace inverse at least we can infer how would be the nature of this function. If the final value theorem is not applied or cannot be applied, that means the perfect relationship which we have found, no, limit t tends to infinity, y of t is equals to of limit s tends to 0, s y s, that particular fundamental cannot be used. But you can't say, but you won't say that the final value cannot be predicted. It can be predicted. It can be predicted, but for that, you had to follow a long process. You had to convert the given y of s into its equivalent Laplace inverse, that would be sine of t. And as we know, the sine of t would be keep oscillating with the constant magnitude as well as frequency, even towards a very large value of t, even when the t is been tending towards infinity. So I can say, if in this problem, if any problem, y of s is being given as 1 upon s square plus of 1, and if they have been asking its final value, so appropriate most answer is going to be in between -1 to +1. -1 to +1. Yeah. I would like to have the another question. Let's take the question has been almost same like the question number second. So question number second. Let's take the question is been y of s is equals to of s divided by of s square plus of 1. May I know what would be its initial value? Final value theorem cannot be applied over here. May I know what would be the initial value? The initial value can be used, and here it's going to be limit s tends to infinity s times of y of s, and here it becomes s square divided by s square plus of 1. And end of the day, what we are going to do over here, the s square has been the common highest degree factor from the numerator as well as denominator. They would be extracted out. It would be left with the 1 plus of 1 upon s square. S would be tends to infinity. The result is going to be 1, and obviously which is a perfectly well outcome, because s divided by s square plus of 1 is being a cos of t, and at t is equals to 0, cos of t had the worth is equals to 1. Had the worth is equals to 1. Could you understand what I am saying? So by taking 2 or 3 different kinds of example or numericals, I just wanted to ensure one thing, that initial value theorem had got only one limitation, final value theorem has got only one limitation. Whether the pole goes towards the right hand side, left hand side, doublet, triplet, I do not care about it. For initial value theorem, only and only one thing has to be there in your mind: the number of poles has to be greater than the number of zeros. Apart from that, you need not to focus over anything. Whether the poles has been a pure imaginary, has been kept towards left hand side, right hand side, does not make any limitation for the initial value theorem. And the same concept goes with the final value theorem. If the number of poles towards the numerator and denominator is being larger, maybe lower, maybe equal, in all of 3 cases, the final value theorem would not have any limitation. The final value theorem has limitation only and only in terms of its location of its pole. If any of the pole goes towards the right hand side of the s plane, or any of the pole becomes a complex conjugate over the j omega axis, that's done. That's done. Yes. So till this point, I don't find any of the student would have any sort of doubt. Now I think it's the right time to take the next question. This has been the question number 2. If Laplace transformation of a time domain function f of t is been 2 had been multiplied with s plus 1 divided by s square plus of 2s plus of 5, then f of 0 plus and f of infinity are given by. The 4 different options were attached along with this problem. The first option states 0 and 2 respectively. That means this has been the worth of f of 0 plus, this has been the worth of f of infinity. The b is being 2 comma 0, c is being 0 comma 1, and d is being 2 comma 5 comma 0. This problem has been experienced by the electronics people in year of 1995. The problem was framed by IIT Kanpur. Tell me what would be the best most answer for this given problem. Whenever you are going to apply the initial or final value theorem, you had to have a clarity whether those theorems can be applied or not, or whether this particular problem has been made or meant for applying the initial as well as final value theorem or not. And I would expect without touching pen and copy, you must be able to answer this problem out. Yeah. Because these are the problem where you can gain the confidence number, and that too without spending much amount of time. So what I am saying, many of the questions which comes in gate examinations, no, they are meant for saving the numbers as well as saving the time. So this has been one kind of the problem which would not take much amount of time, and you would be able to crack it out. So the answers have started coming. As per the Amit Kumar, the answer had been D. As per the Divya, the answer has been B. Anyone else apart from Divya as well as Amit? See, what we are going to do over here, just try to understand in this way. First, watch this function carefully, whether the initial as well as final value theorem is being valid or not. Initial value theorem is perfectly valid because the number of zeros which was contained by this transformed form is being 1 and number of poles is being 2. The number of poles has been greater than number of zeros. Initial value theorem is pakka valid. In the same sequence, if we'll go one step beyond further, and now we have been discussing about the final value theorem. In final value theorem, you need not to focus over its numerator at all. Now, not even you had to focus over the number of poles and zeros, nothing. You just had to focus over the locations of its pole. The location of poles, I think I should say, use the concept of Routh orbits. So if you'll make a Routh orbits, total 3 number of lines you'll be having or rows you'll be having, it is gonna be 1, 5, 2, and here it's gonna be 5 again. So in principal column there had not been any sign change. That means there is no pole towards right hand side. That means even the final value theorem is also valid. That's what I am saying. Without touching pen and copy, you should have a clarity how to crack at least this sort of basic problems. Initial value theorem, perfectly well, sir, we can apply. Final value theorem, perfectly well, sir, we can apply. Okay, let me apply the initial value theorem. What does it mean by the initial value? Initial value, that means I wanted to get the value of f of t around t is equals to 0. Around t is equals to 0, that means you can say t is equals to 0, 0 plus or 0 minus. Obviously 0 plus, 0 plus. Here it had been 0 plus. Yes. So what we have to do over here? Limit s tends to infinity. Keep in mind, whenever you calculate the value at t is equals to 0, you take the reference of limit s tends to infinity. So here it becomes limit s tends to infinity. Agreed? Limit s tends to infinity and s would get multiplied. Once the s gets multiplied, what would happen? It would become 2 times of s square plus of 2 times of s. And here everything would remain very same. And as I have told earlier, whenever the polynomial's degree towards the numerator and denominator would remain very same, in that case the resultant would always be a constant value. May I know what used to be the constant value? The constant value used to be the multiplier of the highest order divided by the multiplier of the highest order. What had been the multiplier of the highest order? It has been 2s square plus of 2s. So obviously it had been 2 and here it had been 1. So simply it's going to be 2 divided by 1. Anyways, from where we have got this answer? So many times we have taken this sort of problem in case of engineering mathematics. So obviously one conclusion I can deduce out of it, and what had been that? F of 0 plus is being 2. And now it's time to calculate when f tries to reach towards infinity. In that case, what we are going to do over here, the limit s has been fed to 0 as t has been tending towards infinity, s would get multiplied, and my dear friend, s has been loosely multiplied and there has not been any component of s towards the denominator such that that s and that s could have been calculated or could have been smashed out. My dear friend, if instead the s square plus of 2s plus of 5, it would have been s square plus of 2s. In that case, this s and this s would have been cancelled out and the answer would have been different. But this has not been the case here. This has not been the case over here. So obviously f of infinity is simply going to be 0. So may I know what's going to be the best most answer? The best most answer is going to be option B. The best most answer is going to be option B. How much time, how much effort, how much number of steps we have taken? No, simply we are writing the answer over here. So that is what I am used to say. Try to strengthen your concept in such that end of the day, number of steps would be reduced drastically, your effort would be reduced drastically, and at the same time you are going to increase your accuracy. So the student who have given the answer as 2, 0, and that has been the option B, that has been the pakka and perfect answer. Is the part clear to all of us? So I would like to ask from each one of you, can I presume that from here onwards you would be able to solve any sort of problem based on the concept of initial and final value theorem? If your reply is yes, just put over the live chat. Just put over the live chat. In the same sequence, now we have come to the next kind of the problem, and obviously it's been a form of simplest problem which has been experienced by the gate electronics year of 1998. Problem was framed by IIT Delhi. Let me read this problem, what exactly it has been meant for. If capital F within the bracket S, obviously it has been a function of S is equals to of omega divided by S square plus of omega square, then the value of limit t tends to infinity f of t, where f of S is being the Laplace transformation of f of t, is cannot be determined, is 0, is unity, is infinite. Tell me what would be the best most answer for this given problem. As we have seen earlier, whenever we are supposed to apply the final value theorem, let me focus a bit about its limitation. We just focus over the locations of its pole. May know where their poles has been located. So we had to just calculate the roots of its denominator's polynomial, and that has been s square plus of omega square is equals to 0, and they had been located at plus j omega and minus j omega. So obviously the final value theorem should not be applied. If the final value theorem cannot be applied, that does not mean that you would not be able to predict how would be the nature of the given function f of t when the t has been tending towards infinity. No, we can, but for that we need to take the Laplace inverse of the given function f of s. So here it's been limit s tends to 0, s times of y of s. Yeah, for calculating the value of y of t when the t tends to infinity should not be used over here. And if you have been using it, definitely the answer is gonna be wrong. So now the manual process has to be followed. For that, we need to take the Laplace inverse of y of s, which would be y of t, and that had been omega divided by s square plus of omega square. It's very same as sine of omega t into of ut. Sine of omega t into ut. May I know how would be behavior of it? The behavior of this time domain signal is gonna be pure sinusoidal. So if I'll say towards the steady state, can't we predict something? Yes, we can predict that it would be keep oscillating with a constant magnitude as well as frequency, where peak to peak voltage is gonna be 2 volt, or I can say the upper voltage would go to the +1 to the -1, and the frequency is gonna be simply 1. So may I know what would be the best most answer? No, it can't be 0, it can't be unity. No, obviously it won't be infinity, cannot be determined is gonna be the best most answer. Apart from cannot be determined, in few of the times the question has been framed in gate that they have given the options as -1 to +1. Obviously it is gonna be the best most answer. But yes, in the same problem you cannot have both as the option. No, either -1 to 1 would be given, either cannot be determined would be given. Could you understand what I am saying? So from here I wanted to say its maximum peak would go to the 1 and -1. So the answer would be cannot be determined, or it would be in between -1 to 1. So what I wanted to say, many of the times the final value theorem would not be valid. Still, if you had to make a certain analysis, for that you had to take the help of Laplace inverse, and from there you can get each and everything. In the same sequence, here goes the question number 4. The transfer function of a linear time invariant system is given by. Anyways, whether this has been given along with this problem or not, but one thing has been quite sure: whenever you had a transfer function in your hand, obviously the transfer function could have been extracted from linear time invariant system alone. Because if your system has been a non-linear, if your system has been a time variant, in that case the transfer function cannot be extracted out. The steady state value of the output of the system for a unit impulse input applied at time t is equals to of 1 will be. I know many of the students would have a little bit doubt specifically for this kind of problem, but no issue. Just play with your basics and try to get its best most answer. You had to find its final value. So in this problem, delayed impulse input has been applied precisely at t is equals to 1. I need to get its steady state response. I need to get its steady state response. Tell me what would be the best most answer. Maximum 1 minute I can give for this problem, and thereafter I would try to explain this problem over the digital board itself. Tell me. 20 seconds more. So the first answer has been received from Harsh Kumar. According to him, the answer would be 0. Anyone else from apart from Harsh Kumar? Chalo. Just start with the basics. Whenever you have this sort of problem, no, the pattern of the problem which we have not seen earlier, just connect yourself from the basics. You need not to go high five. See what had been the problem. The transfer function of the system is pretty clearly given along with this problem. It's been 1 divided by of s square plus of 3s plus of 2. 3s plus of 2. See, as you have been interested finding its final value theorem, you should also have a little bit idea about the validity of the final value theorem. Now it has to get excited with a certain input. May I know what had been that certain input? The input had been delayed unit impulse with 1 second. Yeah. Could you understand what I'm saying? And once you'll take its Laplace, what is going to be the Laplace? X of t minus of a used to be e to the power of minus as, and that has been e to the power of minus a, where the a had been 1, minus of s itself. And now I take the Laplace of x of t itself, and that has been the Laplace of del of t, and that used to be 1 itself. That means towards the output side, we are going to have the output as e to the power of minus s divided by of s square 3s plus of 2. 3s plus of 2. Agreed? No? Yes. This must be clearly known to all of us. Now what is happening over here, as you have been focusing over the final value theorem, one thing is quite sure. You just had to focus over where their poles have been kept up. If we'll talk about the 3 square plus of 3s plus of 2, until and unless if there is no sign change over the first, second and third value, the resultant would be all of the poles being towards the left hand side. So what we are going to do over here, if you have been interested finding the limit t tends to infinity, the output is being taken as y of t. It would simply be limit s tends to 0, and here it becomes s gets multiplied with the y of s. Could you understand what I am saying? S is going to get multiplied with the y of s. End of the day, the result which we can bring out of it, it's simply gonna be limit s tends to 0. The s is going to get multiplied over here, yeah, and here it's gonna be s square 3s plus of 2. 3s plus of 2. Could you understand what I'm saying? So the answer is simply gonna be 0. Obviously, this would be the best most answer for this given problem. I know many of the students could not have got the answer because this has been a little bit different variety of the problem. Yes. Would like to ask from each one of you whether the concept behind this problem have got clear or still have certain amount of ambiguity. Now tell me if this problem has been changed a bit. Instead having 3s plus 2, if we had only 1 divided by s square plus of 3 of s, Whether we would be having the same response or the response would be something different. Response would be something different. That you tell me. No, now the answer is supposed to change. See what is happening over here. Let me copy this portion and let me paste also here. Let me paste somewhere here. See what has been happening over here. What's been happening over here. Limit s tends to 0. Numerator had been very same. The denominator has changed its value a bit. And now it had been this. And now the s has been common towards numerator as well as denominator. What's been happening over here, this s square s and this s goes out. This s goes out. And end of the day, e to the power of minus 0, that would be 1 divided by of it had been 3. So the answer would be equals to of 1 by 3. So you can expect this sort of problem in near future. You can expect this sort of problem in near future, where the answer is supposed to be 1 upon 3. Where the answer is supposed to be 1 upon 3. Yeah, Harsh Kumar, that's perfectly well. That's perfectly well. Yeah. So let me take the homework from my side. This would be the 5th question. This would be the 6th question, 7th question, 8th question, and 8th question. Okay. So I want the reply for this remaining 4 questions over the comment box itself. Because from tomorrow onwards, we are going to jump into the next topic of the control system, and probably I may talk about the block diagram. So this would be the first homework, and that would be the 5th question of the day. Here the steady state value of the output application. Now the input has been a unity step. You had to find this out. In the same sequence, the 6th question, the initial value has to be found. Similarly, in the same sequence, the final value has to be found. And in the same sequence, again, the final value has to be found. Instead giving the transfer function, they have given the block diagram itself. So this is all for the today's class. Precisely, we would be meeting on daily basis 3 p.m. exactly on our GATE Academy Global. And yes, end of the day, the student who may not be aware of it, they must have a little bit idea about the schedule. Electrical machine 1 p.m, power electronics 1 p.m, control system 3 p.m, PSA 6 p.m, EMFT 6 p.m, network analysis 9 p.m. All of the subjects would be on daily basis except electrical machine and power electronics. Electrical machine would be 5 days in a week from Monday to Friday, and similarly the power electronics would be 2 days in a week, and that is from Saturday to Sunday. Yes, so you can follow this methodology and you can learn a lot from our GATE Academy Global. Okay, then we would meet precisely at 3 p.m. tomorrow for the next kind of the problem based on the concept of control system. Till then, bye bye, take care, good night. Here you would, whether you want to be shared this question, I would like to ask from each one of you. Whether you guys want this question. If you want, you can connect myself on my Telegram group. Definitely I would try to share there. Yeah, time of EMFT have been changed. Yeah, okay, then bye bye, take care, good night.